And what are those numbers quantifying?
Current.
Current. Absolutely. It's current just coming out of the transmitter. Which one of those two shots has more current leaving the transmitter?
The bottom.
Does it guarantee that you've got current on the line you're hooked to?
No.
No. You just know you got it leaving the transmitter. Okay? Right. Absolutely. Now, you got one end hooked to earth that you can see. The other end is hooked to a metallic component of an underground pipe or cable. But just because you see a 91, you see positive current, you have positive evidence of current leaving the transmitter, does that mean that current for sure is on the line that you're hooked to?
No.
No. Imagine if the red part of the wire was just hooked to a ground rod too stuck in earth, or a stop sign. The machine would show that current's leaving the transmitter, but it wouldn't guarantee that it's on your line. How do we determine that there is current on the line that we want to locate? It can't be done with the transmitter. What is it that we use?
The
The receiver.
When the receiver is held motionless at a peak response, the tire antenna or antennas become capable of assessing the current level on the pipe or cable at that particular location. Good current is characterized by a still or steady peak response. The current level on the line is termed OK current when the peak response is not entirely steady, but rather fluctuates or flutters within a limited range. Constant and wide-ranging peak response fluctuation is known as poor current. A poor current assessment mandates a change in the deployment of the transmitter. Good current or OK current levels are sufficient levels with which to continue tracing of the pipe or cable.
Current. You gotta have current to locate. If you have poor current, poor locate, yeah, or no locate. All right. So once it got current and it's good, the next step is to look at the signal shape. Is the field round or is it not round? So if I have good current, the next thing I hope I have is a round signal.
Using this single antenna receiver, the peak reading location and the null reading location agree, indicating that the shape of the electromagnetic field is round. This multiple antenna receiver also shows peak and null readings agreeing at the same location. This time, peak and null readings do not agree. This means that the magnetic field is not round and is an indication of an inaccurate locate. This type of receiver response often occurs when you are not locating the target line, but instead a non-target line. The magnetic field leaves the line in either a circular shape or non-circular shape. Although the signal wants to leave the line equally in all directions, the presence of other nearby metallic objects may change that outcome. Other metallic objects energized by the transmitter will work to distort the circular shape of the signal leaving the target utility. There are two signal shapes, round and not round. In general, a round field equates to accurate locate results, and a not round field equates to inaccurate locate results. But this statement is an oversimplification. To extract the maximum amount of information from the receiver regarding field shape, there are 5 methods of receiver utilization. Do the peak and null responses agree at the same location on the ground? If yes, the field is round. If no, the field is not round.
But if peak and null agree in the same spot, then the shape of your field is round, meaning that your locate is going to tend to be on the accurate side. But if you get a peak reading that's here and a null reading that's here, not round. And your locate then starts to be inaccurate.
Obtain a digital depth measurement and then lift the receiver a known distance. Is the difference between the second depth reading and the first depth reading equal to the distance the receiver was lifted? If yes, the field is round. If no, the field is not round.
It just picked up 13 inches. I mean, you guys tell me, is this 13 inches off the ground? Okay. When using digital depth, when you pick it up for a second depth measurement, if it adds the same distance here, our difference is 13 inches. To what it is you picked up. If you picked it up 13, that's an indication that the shape of the field is round. That's the second way of telling round versus not round.
Make sure you know exactly how high you pick the receiver off the ground. If you assume you're picking up the receiver a foot off the ground, but you're only picking it up 9 inches, this method of determining field shape will not provide useful information. This field is round because the receiver was picked up 8 inches, and the second depth reading was 8 inches higher than the first. Also, 3 foot is likely an accurate depth reading estimation since the digital depth validated. This is a not round field because the second depth reading added 2 foot 5 inches when the receiver was lifted off the ground only 8 inches. Additionally, the 7 foot 7 inches depth reading stands virtually no chance of being an accurate depth reading estimation. This type of receiver response often occurs when you are not locating the target line, but rather locating a non-target line. After obtaining a null reading, the instrument is lifted straight up. This lifting of the receiver is along a vertical axis to the null reading. If there still exists a balanced reading, the field is round. If the receiver has to be moved away from the vertical axis to obtain a balanced reading, the field is not round. Peak versus null, the null method, and digital depth validation inspect the field from a vertical perspective.